All right, so now what does this look like if we distill it down to just Sassy, right? And these initial set of components. So the green components are here or imminently here. So secure access, obviously SD-WAN has been around selling for the last 7 years or so. Secure access we launched in June of last year. Cloud web security we launched in June of this year. And so we will have 3 of the 4 boxes filled out inside the Sassy POP. I mentioned before, Cloud Web Security is an OEM of the Menlo security stack, although there was additional work done to build a single pane of glass management through the orchestrator, as well as to build in this Geneve service chaining protocol so that we can do this flexible metadata exchange and pass any pertinent information that either VMware or Menlo discover about what's going on with the traffic back and forth, and use that to feed into our own decision-making on each side. The goal of the initial rollout, which is to 52 data centers around the world, puts us within 10 milliseconds of 80% of the world's metro urban areas, within 5 milliseconds of all major cloud service providers, in most markets, much less than that. In many cases, for instance, with Zscaler, we're less than 1 millisecond away. We were testing L7 health checks together and getting confused by why we were seeing 0 milliseconds because it was accurate. Less than a millisecond, and integer math is fun. So very close to the various cloud providers that we're accessing, very close to vast majority of the user base, and then an expectation that we will close the gap based on customer demand. So the first 52 POPs are decided where they're going to roll out. 33 exist today. 19 of them are new. And so that will cover the vast majority, and then we'll let user demand drive what's missing based on that. And then inside each of these POPs, we have elastic resources to offer scalable and ubiquitous Sassy global services. So the idea is that everything we deliver here should be elastic, should be multi-tenant, should be horizontally scalable, should be able to be given an SLA that is the same as I would expect if I was deploying this on-prem. So I wouldn't deploy an on-prem firewall and then say, okay, I'm going to put that firewall in a hyperscaler who gives me a 3 nines SLA, and that's acceptable to me. We want to make sure that we can deliver enterprise SLAs 4 nines or above for all the services running everywhere, regardless of the access type, regardless of the service. And so various types of cloud native techniques to achieve that. Of course, various types of resiliency models built in both within the POP and across POPs to achieve that. And edge network intelligence, our brains sitting above the POP, which continues to gather more and more data about what's going on so that we can learn when problems occur, what did they look like, how can we fix them automatically, and continue to build more and more intelligent feedback loops to make the service operate in an even more autonomous fashion. Now, there was a question about NSX Cloud Firewall and the reconciliation of policies in the NSX Firewall. So the NSX Firewall will be a later delivery for us, either late calendar year 21, early calendar year 22 timeframe. There's a lot of work to take the NSX service-defined firewall and to make it cloud native, like we said, we were going to require for all of these services that we want to deploy. So we've built in multi-tenancy into the system already. We've built fault tolerance into the system already. We're integrating some of the advanced threat techniques from last line to give us more advanced next generation firewalling capabilities. And we're building again into the orchestrator a single pane of glass for firewall policy configuration. Now, to answer the earlier question about how do I reconcile policies as I move to a cloud firewall model? Well, if you're moving from the NSX service-defined firewall in the data center to the NSX cloud firewall running in our Sassy POPs, it's super easy because the scheme is identical for the policies, and we will just migrate your policies for you and make it very trivial for you. There's a deeper answer to that question, which is what if I have Palo Alto? What if I have Fortinet? What if I have Checkpoint and I want to migrate those policies? How do I know that I'm achieving the same things? That's definitely a problem that we recognize. I don't think I have a great solution that I can give you today for third-party to VMware translation of rules and reconciliation of rules. But we do have products in our portfolio like Verni through a Verifly acquisition who do things around auditing of configs for consistency across various service providers, which we will probably end up leveraging to help us achieve this. So VMware to VMware, very easy answer. Non-VMware to VMware, we're already looking at the internal tools we can use to help us facilitate that use case.
Greg, I know you said it wasn't going to be until late this year that the Sassy cloud firewall rolls out, but are there plans to include things like application dependency mapping, like from NSX into the service as well?
Yeah, so this is the NSX service-defined firewall. The shim that we put on it is to present it to a cloud user by abstracting away multi-tenancy. So giving you a multi-tenant view into what is traditionally in NSX, a multi-tenant data plane, you can think of it as, because the VRFs have strict separation. But the classic NSX manager today doesn't provide a multi-tenant configuration view. So we're up-leveling that so that we give you multi-tenancy. But to your point, the features that are being delivered in the NSX firewall continue to be the features that we will offer to our customers by delivering this. So yes, taking advantage of all of the innovation in NSX firewall and in adjacencies, NDR from last line and other things that we're doing at VMware all become a part of this package. So you can think of the NSX firewall pitch you hear and plug this in here and just think it's getting a new GUI to allow it to be multi-tenant. It's getting a new wrapper to allow it to be cloud scale, but otherwise it's still the same firewall inside. It's still a T0 terminating a Geneve tunnel to per tenant T1s underneath. So if you're an NSX person, it's still the NSX firewall that you know and are used to.
Awesome. Well, that's very exciting. Very good to hear.
A clarification question. Could you explain when it on this slide it's got 10 milliseconds and 5 milliseconds? That's relative to what? I mean, you're obviously physically not that close, right? Driving. So is it relating to some sort of data rate or something?
No, that's absolute latency based on how many POPs we have, how widely they're distributed, and what are the peering relationships we've established with the cloud providers that we are connecting with, like Microsoft, Zscaler, Google, Amazon. So the right side is when we do a service map where we ping all of the major cloud providers from all of our gateways, all of them are less than 5 milliseconds. And the left side is based on analytics pulled from the actual edges that we have deployed. So I mentioned more than 400,000 edges deployed out there in the world. So we know exactly what the milliseconds of RTT are for them to reach our gateways. Again, from metropolitan and urban areas. If you're in Fargo, you're probably not going to get 10 milliseconds. I don't know what the Fargo to Denver latency is, but there are many places in the world where you may not achieve that. But for the vast majority of urban areas in the world, we are able to achieve that, and we can demonstrate that just based on the footprint that we have deployed today.
That's pretty amazing. And your SLA, what does the SLA look like? How much time can you actually expect to achieve that?
So we don't put a strict SLA on the latency itself. We have SLA on uptime, but in reality, the goal is to not add an inordinate amount of latency and to deliver enough value that the latency that you do induce is offset by the additional latency, right? And if you look at like VMware, our own corporate IT team, we did a huge study where edge network intelligence pulls Zoom data for every single employee inside of VMware. So more than 1 million hours a month of Zoom meetings, sad to say, that we're feeding into our machine learning algorithm. What is the quality? And then we're correlating that with where is the user in the world and how are they connecting? Are they connecting through an SD-WAN gateway? Are they connecting through a cloud security service? Are they connecting direct to the internet? And then we built some patterns around what can I expect, right? And what we learned is that latency is not the best predictor. I'm using Zoom as an example, but this could be true across other services. Latency is not the best predictor of whether you're going to have a good or bad Zoom experience within reason. Obviously, if your latency is very high, it can be very bad. But by being able to smooth out network jitter and eliminate loss in our layer of the network using SD-WAN, we're able to deliver high quality experience to things like Zoom, to things like online gaming, for users who don't have low latency as well. So we don't offer an SLA specifically about latency because it's not in our control. Ultimately, we don't own any of the transit that's coming in. So this is more representing our own measurements across our footprint. This is what we actually practically achieve. It's not what we guarantee. It's not what we guarantee we can achieve in the future because we don't have control over those end links. But even in sites where this isn't true, we can clearly demonstrate the value that our solution brings. I think Amanda Blevins tweeted from our Octo team has tweeted about using Starlink and a rural broadband link in rural Colorado to play Elder Scrolls Online, and how, you know, even though she doesn't have the 20 millisecond latency that an online gamer wants, it's using VeloCloud or using VMware SD-WAN, she's able to get a better experience than everyone else she plays with. And that's with a satellite link and a broadband link that has 45% packet loss. So I think latency is not the main determining factor in most use cases.
Yeah, I was curious because I was wondering whether you could utilize this for vehicle to everything kind of communication, which would actually probably require even tighter latency than what you've got here. And also for virtual reality. Virtual reality is still a little high for those kind of applications being done on the edge. So I just wondered, it's pretty impressive, but I was wondering if it's even feasible to get it down even further.
Yeah, I mean, it depends on the applications that you're going to serve, right? And so obviously for any platform we build out, it's going to be driven by the use cases we see. Certainly there are companies like Vapor.io that are pushing the edge much closer to the devices for those use cases like you mentioned, connected cars, right? For us, in the traditional enterprise traffic that we see, we don't see a value in pushing closer to this latency thus far. And that's based on the empirical measurements we're doing of the application performance as reported by the applications themselves and our analysis of them as they traverse our network. So we think for the vast majority of enterprise users, this is good enough. Now, that doesn't mean that tomorrow self-driving cars doesn't become a big use case for the VMware distributed edge and we start looking at ways to push it closer. The good news is the framework is the same. You know, it's flexible enough to do that. So we can deploy more POPs, we can push them closer to the users. We can, using GSM, we can select a subset of services because every service doesn't have the same latency requirements. We can share the low latency POPs with call them super low latency POPs. So we try to build in all of this architectures that foretell that those future use cases might come and support them if they do. That's how we were kind of fortunate with the SD-WAN gateway pivot to Sassy. We already had an architecture that could support it. So prepared for that to become an eventuality. But for us, so far from our customer base, we haven't seen ultra low latency as a hard requirement yet that people are willing to pay for and are looking for us to deliver.
Thanks.
Just one additional question. So we have now NSX on the traditional on-premise environment. We can put it in the cloud. I see still the SD-WAN gateway. So VeloCloud had its own firewall interface. Yeah. Will you put this together that also the NSX code will run on a VeloCloud edge and that we have, let's say, tag exchange and the same interfaces and so on? Is this something on the roadmap?
I mean, there is consolidation that happens between components in a company like SD-WAN and NSX. So we use the same routing stacks now. We use the same IPsec stacks now. So a lot of commonality comes in. I think in the firewall case, it's probably a little bit different. I mean, the NSX firewall is built historically, traditionally built in the data center for east-west firewalling, application firewalling, which is a different use case than north-south in the branch that we're doing. Now, there is some east-west that happens in the branch office too, between, say, PCI VLAN, non-PCI VLAN, but definitely much more of a north-south use case. We haven't yet figured out how much it makes sense to split that. I mean, if you think of it in a true Sassy mindset, Sassy says, minimal infrastructure in the branch, you do your next gen firewalling in the POP. So the branch, what the branch has today, which is a stateful L7 firewall, which can block FQDN domains, which can take a list of untrusted domains and block them all. That serves a lot of the use case of our customers, what they want to achieve in their very small branches. Right?
I make you a classic example, my printer. Yeah, I want to isolate my printer. Now the question for every time somebody sends a print job, do I want to send this to the cloud and back, or do I keep this traffic local? Yeah, that would be a use case for that.
Right, but do you need to do advanced anti-malware on that printer connection, or do you just want to restrict access unidirectionally from one VRF to another?
Printers are a real firewall, yeah, but I see where you're coming from, but from my, let's say, perspective, it would make sense. It don't need to be all the same feature set, but kind of the same interface that I can exchange the tags, for example. Yeah, that would, from an administrative point of view, make it much more easy.
Yeah, I got it. So from an administrator point of view, the orchestrator is your single pane of glass. And from that point of view, you will get a reconciling of the different types of firewall rules that exist. But what I'm saying, at least in phase one, the capabilities that exist in the DC or in the cloud or in the branch will be different. So you can see the rules in one place, you can configure a common set of rules, but depending on where you need to apply those rules, you'll have a different set of capabilities that you can apply.
Yeah, so it will leave me at the end of the day, I have one set of policies I maintain in the orchestrator, the other on NSX, and I still have to maintain both of them. Yeah, so a lot of the traffic that is traversing about from a small branch location, maybe to the centralized data center to cloud assets, then I will be living in these two worlds. Yeah.
Well, the idea is the NSX firewall rules and the SD-WAN firewall rules will both be configured from the orchestrator. So you won't have to go to two places to see them. But you're right that they are two different policy sets. Two different sets of capabilities with ultimately a lot of cases, two different goals that I'm trying to achieve. I'm not usually trying to achieve the same things with my data center firewall rules as my branch firewall rules, but definitely single pane of glass is critical.
Okay, so then I was wrong. So orchestrator does not mean the classical VeloCloud orchestrator. This is more the firewall policy orchestrator in this sense, yeah?
Yeah, that's why I said the VeloCloud orchestrator is now the virtual cloud orchestrator. It's a multi-service. So when you log into the next gen VeloCloud orchestrator, instead of what you used to see, which was an SD-WAN view, the first thing you get is, based on the services you have, a set of services you can access. So edge network intelligence, SD-WAN, secure access, cloud web security, eventually NSX. they're all there as services under this same single pane of glass.
I have a quick question going back to something that you said a few minutes ago. What goes into deploying a new POP, like at a high level?
So the infrastructure components underneath. Now, the infrastructure components may change depending on what services you want to deploy. For instance, if you're only deploying SD-WAN, you don't need NSX and Tanzu. But if you want to deploy the full set of services, you deploy the full set of infrastructure components that provide the runtime environment for all of the services to run on top.